Hello guys, so what we are basically going to do in this lecture is to answer the questions past or previous questions on the naming or the nomenclature of organic compound. So we have these questions from 2020, question 38. It said, which of the following is a tertiary amine? Now I taught you the different classes of amine when I was naming the amine as a functional group, right? Now I told you that whenever you have three groups, if you have three groups or three alkyl group about an amine, that amine is a tertiary amine. How about if you have two alkyl group and one hydrogen, that amine is a secondary amine. Now in a situation where you have just one alkyl group and two hydrogen, that amine is a is a primary amine. So this one is 3 degree tertiary, this is 2 degree secondary, and this is 1 degree primary. So if you are asked which of the following is a tertiary amine, now look at all the options that is given to you. The one that does not have hydrogen at all is the one that is a tertiary amine. The one that lack hydrogen. So if you look at them, which of them do you think actually lack hydrogen about it? Now, about the carbon carrying the NH2, which is the amino functional group, which of them do you think actually does not carry hydrogen? Now, if you look at this one very well, this one is carrying 2 hydrogen close to the nitrogen. Are you getting it now? We are looking at the nitrogen. So this one that carries 2 hydrogen close to this nitrogen is a 1 degree amine. So this is not the correct answer to this question. All right. Now, the second one is this. This is CH3, CH2, NH2, CH3. Now, if you look at this very well, you discover that this nitrogen is carrying 1 hydrogen close to it. Now, when it's carrying 1 hydrogen close to it, what do we say? We said it's a secondary amine. So, of course, this is secondary amine, right? Now, if you look at this one, you discover that this one does not have any nitrogen, right, close to it. Rather, it has 2 alkyl group here, 1 alkyl group here. It means if it has 2 alkyl group here and 1 alkyl group here, it means it has 3 alkyl group above this. If you want to bring this out, you can bring this out as C, and rather, now this side, what do you have here? CH3. Now how about this side? What do you have here? This is CH3, then we have CH2. Then this side, what do you have here? This is CH2, and this is CH3. So you see that this amine here has no nitrogen, has no hydrogen. Are we getting it attached to this nitrogen here? And it has 3 alkyl group. Now, that idea of not having hydrogen is just like a common sense wisdom or a common sense knowledge. The most important thing is that whenever an alkyl or whenever an amine has 3 alkyl group attached to it, is a tertiary amine. Recall that this one has 2 lone pairs of electrons on this nitrogen, right? So the correct answer to this question is this. This is a 3rd degree amine. So option C is the correct answer. Now, this is not an amine at all, because this thing you have here is telling you have C, then you have hydrogen, then you have 3NH3, 3NH2. That's what this is telling you. Like something like this, right? This is the meaning of this. This is not an amine. Is that okay? These are just amino functional groups substituted in methane. Is that okay? So we can say this is tri-aminomethane, if you want to call it that way. So that's basically the correct answer to this question. Now let us look at the next question quickly. Now next question says, name the following organic compound. Now this is also the amine. I don't know why they brought amine here in this question 39, Jupeb 2020. Name the following organic compounds. Now the organic compounds that was given to you is, you have this. Now how do you name compounds like this? According to what I told you, one way to actually name compounds like this is to identify the longest continuous chain. Firstly, identify the predominant functional group. Now the predominant functional group, of course, if you want to look at it, is this amine group here. Are you getting it? That is the predominant functional group. This amine group here is the predominant functional group. So you number from this amine functional group down. Now to the you number to the side that will get to the longest chain or the longest continuous chain. Now I told you that the longest continuous chain may not necessarily be a straight chain. It can be a branch chain. So if we number from here, here will be number 1, here will be number 2, here will be number 3, here will be number 4. This one has 4 carbons. Now let us number the straight chain. This number 1, this number 2, number 3, and number 4. Both of them has 4 carbons. So the straight chain, or let's say the longest chain you can actually get here, is the one that has 4 carbons. So since the straight chain and the branch chain, all of them has 4 carbons, I prefer to take the straight chain. So it means that this group here is a substituent, right? Now, if that group is a substituent, what do you think will now be the name of this compound? Firstly, name the substituent. At what position is the substituent? Position number 2. Now, what is the name of the substituent? We said the substituent is ethyl, right? So, at what position is ethyl? Position number 2. So, you say this is 2-ethyl, right? Is that okay? This 2-ethyl. Then, what other thing again do you have? You have these 2-ethyl. Then, you have the longest continuous chain has how many carbons? 1, 2, 3, 4, which is butane. Now, for the amines, all you need to do is remove the E of butane, which is the alkane, and then add amine to it. So this gives us 2-ethyl, right? Butanamine. That's the name of this compound, 2-ethyl butanamine. Now, there's no need of putting this here. Sorry. Since we have only one substituent, you write these two close together. So this is 2-ethyl butanamine. All right, and that makes option C the correct answer to this question. So that is the answer to this question. Now let us look at the next question quickly. The next question, let's erase this. Now next question says, the following compounds, right? The compounds are these. Say, how are the following compounds related? You have C6H13NH2, right? And then you have C3H7NH2, and then this CH3CH2NH2, and then CH3CH3NH. Now the question is, how are these related? Now, all these are amine. They are classes of organic compounds called what? Amine. So, how are they related? Are they chain isomers? They are not isomers, because isomers are compounds that have the same molecular formula but different structural arrangement. So, they can never be isomers. So, anything that has to do with isomers here, you can strike it out that this can never be the answer, right? Because all of them, they don't have the same molecular formula. This is C6, this is C3, this is C2, if you want to count 2 carbons, and this is C2, also 2 carbons. So they are not isomers. So the idea of isomerism is out of the way. Now the next thing is, are they primary amine? Now if you look at this one very well, from the look of things, you may say that this is a primary amine, but in the real sense, it may not really be a primary amine. All right, but if you want to actually count, if you want to draw this, this is like something like this, and then you have, or it may not even be cyclic structure, it may just be a straight chain compound, CH3 C C C C C. This 1 2 3 4 5 6, 1 2 3 4 5 6, right? This hydrogen, 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 hydrogen. We have hydrogen, hydrogen. We have hydrogen, hydrogen, and then we have NH2. That's the meaning of this structure you have here. Now, if you count this, how many hydrogens? 3 hydrogen. So we have 3, we have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Are you getting it? That's why we have C6H13NH2. If you look at this very well, this is a primary amine. Why? Because it has just one alkyl group. You can classify this whole thing here as one arrow group, right? According to what I taught you. So if you classify this as one arrow group, and for the fact that it's actually having 2 hydrogens attached to the nitrogen, you can take it as an alkyl. So this gives us NH2. Is that okay? RNH2. And this makes this a primary amine. Now, how about this? This is also a primary amine, since you have H2 here, H2 here, H2 here. All these are primary amine. But when you come to this one, is this a primary amine? Now look at this very well. This is having just one hydrogen attached. So it means you have two alkyl group. That's the meaning of that. Where one CH3 is to this side, the other CH3 is to this side. Of course, you have the lone pair of electrons here. Now, this compound you see here is a secondary amine. Now, why do we say this compound is a secondary amine? Because it contains two alkyl group, which is this one, attached to the nitrogen. So you may want to represent it as something like this. Let's say the two lone pairs, hydrogen and this. So this is a secondary amine. So you cannot make the judgment that they are all primary amine. But another thing again is, are they homologous? That means, are they homologs rather? Homologs are the members of the homologous series. Are you getting it? The members of what? The homologous series are called the homologs. Is that understood? Now, if you look at them very well, all of them, they are amine. Whether primary, secondary, or tertiary, they are all amine. And they correspond to the general formula of CN H2N plus 1 NH2. This is the general formula of the amine homologous series. If you take this orthocognizant, for instance, this is C6. So this gives us C6. It means N is 6. Then you have H. 2 times 6 is what? 12 plus 1 is what? 13. Then NH2. It means that this first one corresponds to that. Now, let's take this one, C3. It means N is 3. So this gives us C3H. 2 times 3 is what? 6. Plus 1 is 7. 7. And then NH2. It corresponds to this. Now, how about if you take this one? This is CH3, CH2. That means C2. So, if you take this one too, following the same procedure, you have it as following the same procedure. That is C2, right? So this will give us C2. It means N is 2. H. 2 times 2 is 4. Plus 1 is what? 5. And then you have NH2. Now, if you look at this very well, this is C2 because there are 2 carbon here. How many hydrogen? 3 plus 2 is 5. C2H5 NH2. So it means it also corresponds to this. Now, how about this one? CH3 NaCH3. It's still the same thing, right? Let us examine this one if they follow the same homologous series. This one too. This one makes it disqualified, but there are 2 carbons there. The general formula is this. So this is supposed to be, since there are 2 carbons, it's supposed to be C3. Then you have C2. Okay. Because of one hydrogen has been used to, they use one hydrogen here. It's supposed to be 2 hydrogens here, right? But they use one hydrogen here to actually form bond with this, right? So we have, if you want to count that, that would be C2 because you have 2 carbons. Then you have H5 because 2 times 2 is 4 plus 1 is 5, and then NH2. But they use one hydrogen, carried one hydrogen here, so that it will form a secondary alcohol. So this gives us C2H6 and then no hydrogen here, right? Which still correspond with the general formula. So we can say this corresponds with general formula, and all of them correspond with the general formula. Hence, you can call them homologs. So the correct answer to this question is option B, which is homologs. Is that okay? So that's basically how to go about a question like this. Now, when you see questions like this, you may want to just quickly look at them and say they are isomers or they are primary amines. Please make sure that you dissect it like this in order to get the relevant answer. Is that okay? Let us look at the next question. The next question says, all right. Now let us look at the next question. The next question says the name of this compound is. Now you are given this compound CH3. CH triple bond CH2 COOH. Now you are given this compound, you are asked to name. Firstly, we were told that the carboxylic acid is one of the most predominant functional group in organic compounds. That means it has a higher priority than most other functional groups. So we can actually take this as the parent name of this compound, which is the carboxylic acid name, right? So if we take that as the parent name, let me just erase this off so that I can rewrite it again. This is COOH. and then start our numbering. Now, the reason why I have to do this is so that we get the right numbering. So we number from the side where the functional group is. So here gives us 1, 2, 3, 4, and 5. Now, since the carboxylic acid functional group is the predominant, it means it will take the parent name. Now, if it will take the parent name, it means that this group here, which is the triple bond of alkyne, is a substituent. Now, how do you name compounds like this? Firstly, we can decide to say, let us count from here 1, 2, 3, 4, 5. There are 5. That means you have something like pent, right? So the name of this compound will start with pent, since it's pentane 5. So we have pent. Now the alkyne functional group is at position number 4. You can put dot here and then put 4-ine. Are you getting it now? And then you can put 1 oic acid. Now, in most cases, you may decide to just remove the 1 because it's the same thing as oic acid. So this gives us pent-4-ine oic acid. Why? Because of the alkyne functional group, which is pronounced as ine. It's supposed to be pent-4-ine, right? With just this alkyne, pent-4-ine, before you now call the predominant functional group or the functional group with the highest priority here, which is the carboxylic acid. Now, the carboxylic acid are named by changing the E. So normally this is supposed to be pent-4-ine, right? But carboxylic acid are named by changing this E to what? OIC. So this gives us pent-4-ine oic acid, right? And that is the name of this compound. So that is basically all for this. Now let us go to the next question. We've not actually circled our answer, so our answer is option D, pent-4-ine oic acid. You cannot say it's 1 pentyne 4 oic acid, because if you are doing this, it means you are saying that the alkyne functional group has a higher priority than the carboxylic acid. So this is wrong. Pentyne 1 oic acid, you didn't state the position of the pentyne group. That is wrong. 5 pentyne 1 oic acid, no, the pentyne is not in the 5th carbon. So this is wrong, and this is the correct answer. All right, so let us go to the next question. Next question says, a family of compound in which each member differs from its successive member, a family of compound which follow a regular structural pattern such that each members differ from the preceding by CH2 group. We say CH2 group is also called methylene, right? And it has atomic number of CH2, atomic number of 14. It's termed as, we said this is called the homologous series. The homologs are the members, but the series are called the homologous series. So you cannot choose homolog, but rather choose homologous series as the correct answer to this. Next question. What is the IUPAC nomenclature of this compound? It's very easy. Now, this is a very simple question. This is a gift to you. This is CH2, then you have CH. Of course, you know this Cl will be on top here, and then you have CH3. So our numbering, of course, will be from this side. So here is number 1, here is number 2, here is number 3, here is number 4, here is number 5. So by now you should be able to number organic compounds like this. So this, at what position is the chloro group? Position number 2. The chloro group is a substituent, and then the pentane is the predominant functional group here, or let's just say is the one that have the longest continuous chain. So the alkane series, we take the name here. So this gives us 2-chloro, right? So this is 2-chloropentane, and that makes option A the correct answer, 2-chloropentane. Is that okay? So that is the correct answer to that question. Now let us look at the next question quickly. The next question says, this Jupeb 2019 question 42. The question says, let me take this pen. The question says, the IUPAC name for the compound below is. Now the first thing you need to do is to identify the longest continuous chain. Now I told you that in most cases the longest continuous chain may not necessarily be a straight chain, as you may need to take a branch in order to ascertain it. Now, based on the things that we've learned before, based on what we've learned before, you agree with me that this chain here is continuous from here. Are you getting it? and then it goes from here to this place, will definitely be the longest continuous chain, because if you count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So let us count the longest continuous. Let me circle it out, or let me get out the longest continuous chain here. So these are chain, and then we have something like this. I may decide to take this one this way so that I can have space to accommodate that, right? And then you have this one too as part of it. So I can decide to take this one here as part of the longest continuous chain, and then continue from here. So all these ones that I just took here are the longest continuous chain. So the longest continuous chain is this chain that runs from here like this down to this place. Is that okay? Now, how do we number? Are we to number from this side or to number from this side? Now, it means that each of these ones you see here are what? Substituents. True or false? True. Now, are we to number from this side or to number from this side? Now, according to what you know, you are told that when you are writing the substituent, you should always, and when you are numbering, you should always number to the side that will get to the substituent first, right? Or easily. So if you number from this side, this will be, let's start from this side. Let's start with the wrong one, because automatically this is the wrong one. If you are very sharp and you've been following the lectures we've been having, you should be able to look at this and tell me the answer. So this is 1, right? And here is what? 2. Here is 3. Of course, here is 4. Here is 5. We got to the first substituent at number 5, and that is not too good. Now, if you count from this side, this is 1, 2, 3. Now, we got to the first substituent at position number 3. Then you have here is 4, here is 5, here is 6, here is 7, here is 8, here is 9, 10, and 11. So that is the numbering pattern for this question, right? Now, what are our substituents? They are all methyl substituents. Is that okay? So since they are all methyl substituents, it means they will form the same name, but you have to use a prefix for them to indicate their numbers there. So at what position are they? You have one at position number 3, and you have another one same at position number 3. So you come here and say this is 3, 3. Now you have the other one at position number 7, and even this other one at position number 7. So you have 3, 3, 7, 7, and then how many are they? They are 4. Now, for prefix, you use tetra. So you say this is tetra, right? Methyl, and then tetramethyl what? Undecane. Now, why is it undecane? Because the alkane has 11 carbons, and we said the homologous series that have 11 carbons for alkane, or the homolog, the member of that series that have 11 carbon for alkane, you call it undecane. Then if it has 12, you call it dodecane. If it has 10, you call it decane. So this one, you say this is tetramethyl undecane. All right, tetramethyl undecane, and that makes option B the correct answer to this question. 3377 tetramethyl undecane. Now, that is that. All right, so that is the correct answer to this question. Now let us look at the next question quickly. Next question says, when the common names are used, right, for naming, are used for acid, the underlying carbon atom in the molecule shown would be designated A. Now, when the common names are used, right, when the common names are used for the carboxylic acid, this group here is called the functional group, right? Now, if you have the carboxylic acid, let's say this is a carboxylic acid, COOH, and then you have, along this line, you have other carbons. Let's say this carbon 1, carbon 2, carbon 3, carbon 4, like that. Now, this carbon here is called the alpha carbon. This is called the beta. This is called the gamma, and it continues like that. These are called the Greek alphabet, right? Like the way you have A, B, C, D in English alphabet, still the same way they have their Greek alphabet. Now, this alpha, beta, gamma, then you have the last one as omega, which is the last Greek alphabet. Something continue like that until you get to omega. That is why you have alpha, omega, beginning and the end. Say, I am the alpha and the omega. You know, some part of the Bible, most part of the Bible were written in Greek, right? I am the alpha and the omega means I am the beginning and the end. Same thing applicable, like A to Z means from beginning to what? Ending. Are you getting it now? So when you use that, this carbon, this group here is the alpha carbon. The one adjacent to the carboxylic acid group is the alpha, while the next one is beta. The other one is what? Gamma. So when they say this underlined carbon here, what would you say? This one is the alpha carbon, this is beta carbon, and this is what? Gamma. Now, I didn't actually talk about most of the common naming, but you have now known it now. So when you talk about common naming, especially for the carboxylic acid, this is the procedure to follow, and that makes option B the correct answer. Correct answer is alpha. So correct answer there is alpha. For common naming, the carbon underline is alpha. How about if it were to be this carbon that was underlined? What would you say? It would be beta. How about this one to be what? Gamma, and so on and so forth. Alright, so that is the correct answer to that question. Now let us go to the next one quickly. The next question says, draw the structure of the following compound. So we are going to draw the Jupeb question. This is not question 42, this is a theory question. Say, draw the structure of the following compound: 2-bromo, 3-chloro, 4,4-dimethyl pentana. Now, firstly, you have pentana. Pentana is telling you that it's an aldehyde. This now is telling you that it's an aldehyde functional group. So for the first one, pentana means you have, firstly, CH3. Let me just put this one, CH2, 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 and then you have C double bond OH. Now, this is the pentana, the aldehyde functional group, which I told you they have the general form of C double bond O and then H, ROC double bond OH. Now, our numbering, it just seems as if we are trying to name the compound again. Our numbering will be 1, or let's say this number 1, this 2, this 3, this 4, this 5. Alright? So, now you were told that at position number 2, you have bromo. So, it means you erase one hydrogen from here and then put here as bromo. At position number 3, you have chloro. So it means you erase one from here so that the valency of carbon will be balanced. Are you getting it? And then you have chloro. Now, at position number 4, 4 and 4, you have dimethyl. Now, if you have dimethyl, for everything, for every substituent you attach, remove one carbon, one hydrogen rather. So if I add one substituent now, which is methyl, CH3. Now, at position number 4 too, we have another substituent. So I'm going to erase one of this again. And then I have CH3. So that is the name of the compound. That is the compound they want you to draw, which is this. Is that okay? So this is the compound for the first one: 2-bromo, 3-chloro, 4,4-dimethyl pentana. Is that alright? Now the next one is. So we have the one for butane 1,2,3 triol. Now I told you that when you want to write structure like this, first of all, write the butane. Butane will be CH3. It has 4 carbon, CH2, CH2, and then CH3. Now, if you look at this very well, you are told that at position number 1, there is OH group, 2, there is OH, 3, there is OH group, because this triol means 3OH. Are you getting it now? So we come here. If we say let this be position number 1, here be 2, here be 3, here be 4. What I'm going to do now is to erase. Now, whatever hydrogen you are removing here, or if you want to make any substitution, you should always remove one hydrogen in order to balance the valency of carbon. So same thing applicable here. Remove one hydrogen to be remaining only one here. Since position number 2 we also have an OH. Position number 3 we also have an OH. So remove the hydrogen from here. And then we have OH. Alright, so this is the structure of butane 1, 2, 3 triol. Alright. Alright, so let us write for the next one. The next one is 2,4,6-tribromophenol. So the first thing we are going to do now is to draw the structure or write the structure of phenol. Phenol is something like this. Alright. Then it has all these. and then of course you have the OH group here. So if you want to number, it means here will be number 1. Now you are told that number 2, this number 2, number 3, number 4, number 5, and number 6. So you are told that at number 2 there is a bromine group. So you come here and put B arrow here. Now number 4, there is also a bromine group. So we have B arrow here. At number 6, there's also a bromine group. So we have B arrow here. Alright? So this 2,4,6 tribromophenol. And that is the structure. Is that okay? Now let us look at the next. The next is write the structural formula for each of the following and indicate whether it is primary, secondary, or tertiary. Now you have 3-pentanol. Now what do you think will be the structure of 3-pentanol? Something like this. Pentanol is CH3, CH2, 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 and then CH2, CH3. This is pentane normally, right? 1, 2, 3, 4, 5. This pentane. Now you are told 3-pentanol. It means at position number 3 there is the OH group. So I'm going to erase this here and then put one OH, right? Now this is the structure of 3-pentanol. Now the question is 3-pentanol, is it primary, secondary, or tertiary? Now from everything you've learned, you agree with me that this is an alkyl group. This is another alkyl group. Now I told you specifically that when you have two alkyl groups surrounding a particular carbon, you call it a secondary alcohol, right? So this is a secondary alcohol. Another thing again, you have to look, the carbon, is it carry just one hydrogen? If it's carry one hydrogen, then it's secondary alcohol. So this is a secondary alcohol. So that is what you ought to do in this question. Now the next one says 2,2, so this is for I, and then you have II. II says 2,2-dimethyl 1-propanol. So first of all, let us write propanol. Propanol, 1-propanol is CH3, CH2, and then CH2OH. Now it says 2,2-dimethyl. It means if here is position number, supposed to use this pen. Anyways, let's just manage it. If here is position number 1, here would be 2, here would be 3, right? So it means 2,2-dimethyl. It means at this position number 2, you have 2 methyl group attached here. That is the meaning of that 2,2-dimethyl. So we can decide to come here, right? And then put CH3 here and put CH3 here. So this is 2,2-dimethyl 1-propanol. Now the question is it a primary alcohol, secondary alcohol, or tertiary alcohol? Now if you look at this very well, this is a primary alcohol. Now the reason why you call it a primary alcohol is because this whole thing here is just one alkyl group, right? So it's similar like one alkyl group, which is arrow, attached to CH2OH. Are you getting it? And of course you can see that there are 2 hydrogens here. Told you that when it is 2 hydrogen, you call it a primary alcohol. Now the next one is 2-methyl-2-propanol. 2-methyl-2-propanol. Now first of all, let us write 2-propanol. 2-propanol means at position number 2 there is the OH group. So we have 2-propanol like this. Now also at position number 2 there is another methyl group, which is CH3, because if you want to count, you count from this side, any of the side, right? So we can go by saying that this is 1, here is 2, here is 3. Now this is one alkyl group, this is another alkyl group, this is another alkyl group. So you see 2-methyl-2-propanol has how many alkyl group? 3 alkyl group attached to this carbon here. So here is OH. Now I told you that whenever a compound has 3 alkyl group, what do you normally call it? This compound, whenever an alcohol rather has 2 alkyl groups surrounding this carbon carrying the OH, you call it a tertiary alcohol or a 3-degree alcohol. So basically that is all, and this is question 42. This is not question 42, this is theory question 2015, I bet so maybe just a mistake from my own end. All right, so that is basically all for this session, I think. Is there any other question again? No. Is there any other question again? I don't think there is. Let me check. Okay, so we are done with answering all the questions under the nomenclature of organic compound. So thank you very much for your time. All right, bye bye. We'll see you in the next lecture.